Okay, so welcome to Math2526. So this class is a continue for the topic for one-way table, two-way table. So we know what is one-way table, what is two-way table. Like this is a two-way table, like this one is a one-way table. So for two-way table, the typical question is like changing this direction, or changing this direction make a difference. So for one-way table, we one-way table, the typical question is this data fit the model? So typical question for one-way table is this: do the data match the model? So we have data. So the model is our assumption, right? So we let's say so we have the graded distribution for our class. So we have how many A, how many B, how many C, how many D or F. So whether this our data, our graded distribution fit the model or fit the percentages for getting A and B or C or D for all other classes. Okay, or let's say suppose our department chair will complain in your class there is grade inflation, too many A, too many B's, just like that. So how can I defend myself? Okay, so here we just want to check it out. So what is the grade inflation? What is inflation? Grade inflation meanings? Or how can I say no grade inflation? So if there are no grade inflation, means our class grades and other class grades distribution quite the same. Or so for other class, we have the percentage for getting those grades are 20%, 30% like this. Like 20% got A, 30% got B, 40% got C, or 10% got D or F. So this is our assumption or our model. Okay, so we call this is just the model. Those percentages as a model. So we just wanted to check whether our data, our distribution fit this model. Okay, so according to this model, according to those percentages, so we can find those expected value. So this expected value is just like according to your percentage, like 20%, let's say, for getting A. For getting grade A, so 20%. So we 20 is 0.20. 20% multiply, so total students. So we find totally total we have so many, it's like 6 plus 12 plus A plus 4, right? So equal 30. So we say totally we have 30 students. So according to this percentage, 20% got A, so 20% of 30, so equals 6, right? So this is expected value. So for B, we say 30% got B, so 30% of 30, we find 9. So we can get those numbers, 6, 9. So here the 12, 40% of 30 is 12. So here we have observed value and expected value. So we can find the chi-square value. So chi-square value, same formula. So chi-square value is just equal summation of those observed value minus expected value square over expected value, right? So this formula is the same. Chi-square value formula same. So for this very small data, like one-way table, so for this small data, we can do those calculations by Excel, by hand, or by calculate even. So we say we can find this chi-square value. So 6 minus 6 square over 6, right? So this minus this, now observed 12 minus 9 square over 9. So 8 minus 12 square over 12, right? So 4 minus 3 square over 3, right? Okay, so we find this number is 2.67. Okay. So now we have this cutoff point, or we saw this is test statistic. So we want to determine this number is small or big. Small or big. So we just check this number, small number or big number. So we say if this number is small, then this means the observed value and our expected value quite the same. So we can say the data matches our assumption. Data matches the model, right? So if this number is big, there's a cutoff point, or there's a test statistic, there's a chi-square value is big, then we say, the true observed data and our expected data, they are differ very much. So we can say like over class grade distribution, and other for the universities grade distribution not as close, right? So we can say there is a grade inflation, right? So let's say that, do we have a grade inflation, or is there grade inflation or no grade inflation? Just depends on this. This number is a big number or small number. Okay. So how can we judge this number is a big number, small number? So we need to check some table, right? So here check a chi-square table to find. We say find critical value. Critical value. So use that value to make a judgment. Yeah. Critical value. Right. Use that number to judge this big number, small number. Okay. So in order to check the chi-square table, we need to know degree of freedom. So here, degree of freedom is equal C minus 1, so equals 3. So here, C means column. So for two-way table, remember the degree of freedom for the two-way table is thus. R minus 1 times C minus 1, right? So this is for two-way table. So for one-way table, we cannot apply this formula for two-way table because R equal 1, right? So if we plug R equal 1, degree of freedom becomes 0. So we for one way table, we should use this formula, C minus 1. Okay, so there's a degree of freedom is equal 3. So we say for two-way table, why we have this formula for degree of freedom, that df equals R minus 1 times C minus 1. So such explanation can be tough, can be complicated, but explain this one, why degree of freedom equals C minus 1. So this is actually easy. Like let's go back to our example. So here we have totally we have the 30 students in our class, right? So the 30 is fixed number, right? So we just put this 30 into 4 categories. So we say like if we have 3 of them, like if we have A, B, C, then the number of grade for D or F is determined, right? So we can say we can only have 3 number can change. Like you can put any 3 number for A, B, C, like or A or B, C, D, right? Then the remaining one is fixed. So only 3 can change freely, right? So degree of freedom is 3. Okay, so but anyway, so degree of freedom, the formula is simple, right? So we use this formula. Then check the table. Okay, so let's say check chi-square table. So let's see. I attach here. So you can check the chi-square table online. You can find those table online easily, right? You type in Google, you type chi-square table, it will give you several chi-square tables. So you just need to understand so what are the table meanings. Right. So here degree of freedom is 3 and probability we pick 0.005, this one, right? Okay, so we get this number, so this is just the critical value. Okay, this is critical value. So we can use this number 7.815. We use this number. This is critical value. We see critical value 7.815. So use this number to make a judgment. This big number, small number. So we say like here's 0. Here is critical value. Okay, so we can use this as a cut point or as a standard. So we can say those number here, the number here, a small number, and the number here like a big, above 7.815 is a big number. Okay, so our number is here 2.67. So we can say this is small, right? So it's a small number. Okay, so we put it to here. We say so 2.67. This is small number, right? Okay, so if this is small number, so we can get our conclusion. So our conclusion is their difference is small, or observed data and you expect data or the data and our assumption or the model differ very small, so quite the same, right? So we can say our conclusions are there is no grade inflation. So our data, our grade distribution match this model quite well, right? So no grade inflation. Okay. So this example is simple, right? So we say like find the expected value. So expected value is just the total number multiply the percentage. Then we can calculate the chi-square value. Okay. So here we say if we have only 4 cells, then the find the chi-square value is easy. So we should be able to do those calculations. So if we have many cells, so usually we prefer to use Excel to do those. So Excel is easy for calculation. So I encourage you to do complete calculation by Excel. Okay. So now let's check one more such example. Okay. Okay, so here the question is this landing machine really landing? Or so we want to check the quality for this landing machine, whether this landing machine uh, can be uh, can be used. Right? So to test this, we just run this machine 10,000 times. So we just count how many zero or how many digits zero appear, how many digits one appear, how many two appear. So we can have this table. Okay. 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 So based on this table, so what we wanted to uh, say is I wanted to answer this question, right? Is this machine landing or not landing? Okay. Or the quality of this machine is good or not so good. So we want to make our conclusion at this significance level. So alpha equals 0.005. Okay. So at the first we need to find expected value. So this is the observed value. Actually, so this expected value. So we say all the digits should have the same chance to appear, right? So this means that each digit should have 10% or evenly. So we run this 10,000 times. So each one expected value should be 1,000, right? So 1,000, 1,000, 1,000. Each digit should appear 1,000. So then chi-square value is like this. So equal this number, let's say like 935, this observed value minus expected value square, then over 1,000. So plus, so second CO like, okay, this, right? Minus 1,000 square over 1,000. Okay, so here we have 10 cells. So such a calculation can be tedious. So we prefer use Excel. So Excel, you just need to put the formula for first one, then you can copy the formula, then you can find all cells, all those numbers, then just add them up. Use the sum function, add them up. So now suppose like we find this chi-square will cut point this 35.8. I hope like you can try use Excel to confirm this. Okay. Here I cannot show you this use Excel here. But anyway, like okay. So once we have this number, so we just check out bigger or small, right? So just this question, bigger or small. So how can find this number, the big number or small number? So we just check a chi-square table, find critical value. Okay. And the degree of freedom, so here is 9, right? So equal degree of freedom equal C minus 1. So here C equal 10, right? So this equal 9. So I remember this degree of freedom. So degree of freedom equal 9 from the chi-square table. So equal 9, and check 0, 0, 5. So you can find this number. So this number is chi-square, is a critical value. So I think this is 9 point something. Yeah. Okay. So compare this number. So we can say this is big number. Okay, this is big. So the 5.8 is a big number. Then our conclusion, our decision is, so this landing machine is not landing. Okay, so this also means like the percentage for produce so the digits are not the same. They have some difference. Okay, so for this question, we just use a chi-square test. We answer this question. So actually, so for this problem, we also can try other methods. Just let's say like compare. So we just check highest one and let's say lowest one. Yeah, I think this like. So I can check like whether their percentage quite the same. So we can say like P1 hat. This equal like we just check highest is says 1100 over 1 over 10,000, right? So this percentage is 0.11, right? And the other percentage is 920, right? 920 over 10,000 equal 0092. So we also can check whether this like 0.11 or 110 or 0.092. These two percentages are quite the same or not the same. So if this percentage is not the same, so then we can say this landing machine is not landing, because produce these two digits, the percentage are not the same, right? So we can also answer the question by two sample problem, like compare two percentages or two proportions. So compare two proportions, we use this formula. The cut point is, let's say, like, do you still remember this? The P1 x bar like P1 hat minus P2 hat. Okay, like x bar minus y bar. Then take square root like PQ over N1 over N1, PQ over N2. So do you still remember this formula? So this is the two sample problem. Okay, so here we can plug in this. So let's say, so this equal this is 110 minus 0092. Okay, so here take a square root of, so PQ is the P hat Q hat. So P is 0.110. Then Q is 0.89, right? So over, what is N? N is 10,000. Okay, so PQ over N1. So for this sample, the N1, so okay, and also the here, so N, so PQ, so this equals 0092. Then multiply 0.9, I think 08. So over 10,000. So just this calculation, and then so use Excel to do those calculation. Or we can, I did this. I find this equal like 4 point something. 4 point. Let's say I put some number. Okay. Okay. So then we just determine this big number, small number. This number, big number, small number. So which table we need to check? As we say, this is T table or Z table. So this is because the sample size is quite big, so this is just the Z table, right? So we check Z table, find cutoff point, find critical value. So Z table, find critical value is this cutoff point such that this is 0.005. So this is a critical value. So we find this is equal 1.65. Okay. Okay. So judged by 1.65, so we can say there's 4 point something. This is a big number, right? So this is a big number. Then our decision is there's 2% differ very much, right? So this landing machine is not so landing. Okay. So answer this question, we can regard this as a chi-square test, or like we can regard it as a one-way table problem, right? Also, we can regard this is two proportion compared to proportion problem, or two sample problem, and also we can conduct a one sample problem. So one sample problem is like we just check highest or lowest. The highest is this. So there's 11%, and the supposed percentage equal 10%, right? So from our data, we find this percentage is 11. So we just check their difference is big or small. So this is a one sample problem, right? So how can check this, test this one sample problem? So we say use this use this formula, x bar minus, remember this from x bar this, x bar minus mu 0 over, so sigma is radical PQ, right? So here, what is P? What is Q? So P is 10%, Q is 90%. PQ over N equal so thus, right? So this value is Z value. So we also can check then. Once we find this value, so we can check this value, big number, big value, small value, right? So I think this is also big value. So if this big value, so we can say this 11% and or 10%, they are differ too much. Okay. Okay. So we say like this problem. So for that question, we usually have many ways, as long as your way is make sense. Okay. So here, like we can regard this as one-way table problem, or regard it as a two sample Z test, two sample problem, or one sample problem, right? So usually we can get to the same conclusion. Okay. Okay. So this today's topic is just a continue for two-way table, one-way table issue. So we finish this topic. Okay. So we say one-way table, two-way table, the problem quite the same. We find this chi-square value, just a cut point, right? Then determine this number, this cut point is big number, small number. So we just check a chi-square table, find a critical value. So here, check a chi-square table, the degree of freedom. We have two formulas. So one-way table is this, C minus 1. The two-way table, so I minus 1, C minus 1. Right? Okay. So we say that this is we finish this topic, one-way table, two-way table. Okay? So the process is quite the same, right? Okay, so we can stop here. So thank you for our next class.